Okay. Bismillah ar-Rahman ar-Rahim. We'll continue doing this section 9.4. Now we'll have this series 5n minus 1. Yeah, very clear. My comparison series will be what? Yeah, 1 over n. Very clear, it will be 1 over n. So this is my bn, and my an is 5 over 5n minus 1. I don't know, this is diverge, harmonic series. So now what will happen with the limit an over bn as n goes to infinity? That will be what? 5 over 5n minus 1. Reciprocal of this, n over 1. So I'm getting 1. Huh? So both diverge. So this series diverge. Okay. Next one. Yeah, this is a little bit odd. What do I need to do? Let me look at this. This is 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus. This is will be less than 1 plus 1, 1 plus 1 plus 1 over 2 plus 1 over 2 squared. This is 1 over 4. This is 1 over 6. So 1 over 6 will be less than 1 over 4. This is 1 over 2 to the power 3, 1 over 8. This is 1 over what? 24. 4 times 3 times 2. Yes, 24. And so on. So if you look at this series, it's what? It's 1 plus summation n equal 1 to infinity, n equal 0 to infinity, actually, half to the power n. But at n equals 0, I'm getting 1. This one, just a number. This is half. This is 1 over 2 square, 1 over 2 cube, and so on. And this one, I know it's converged. Yeah, because it's geometric. With r equal half. So absolute value of r less than 1. This is converge plus 1. So for sure converge. So everything is converged. And this one, so this is my bn. So I know that, and this is my original sequence, an, huh? This is my an. Or the, yeah, an will be 1 over n factorial, and bn is 1 plus summation half to the power. Yeah, how to write it? Let me write it as a series. So series an is series 1 over n factorial, starting from n equals 0. Summation of bn is 1 plus summation half to the power n, but n equals 0 to infinity. Okay, and this is now the smaller. This is the bigger. And this is the smaller. And they know the bigger converge. So for sure the smaller, which is summation 1 over n factorial, converge. That will be my answer. Okay. I have this limit conversion test, which we did before. L is finite and positive. As I said at the end of the last video, we have now, this is finite and positive. Is that all? We have also two cases. By the way, these are exercises 63 and 64 in the book. Huh? In the book, in our book, in this Larson book. Okay. So if the limit is equal to 0, I cannot say both are converging or both diverging. No, but we have a special case. If the limit is equal to 0 and the series, the Bn, the series of the one in the denominator is convergent. Then the one in the numerator converge. Not only that, also we get infinity the other way. If the series in the denominator diverge, then the series in the numerator diverge. So I have these two more cases, which is more than. So if the limit is finite and positive, very clear, both converge or both diverge, I don't care. However, if the limit is equal to 0, then, and the limit of the denominator converge, or not the limit, I mean the series in the denominator converge, then the series in the numerator converge. And the same thing for the infinity the other way. And I make it in one table. Now it has everything. If the limit is C, positive and finite, خلاص, both converge or both diverge. If the limit is equal to 0, and this series converge, then the series in the numerator converge. Infinity, if this series in the denominator diverge, then the series in the numerator diverge. Okay, sometimes he will give you the series not written in the not in terms of n, so we need to rewrite it again. Okay, look at this one. This one, if I want to make the n term, it will be what? It will be summation. Let me say n equal 1 to infinity. Okay, this is what? This is 2 plus 1. This is 2 times 2 plus 1. This is 2 times 3 plus 1. This is 2 times 4 plus 1. So I have 2n plus 1 over. Okay. This one is what? This is 2 square. But notice I have n equal 1. So this is n plus 1 square. This is 3 square. This is 4 square. And this is n, yeah, n plus 1, when n equal to, n equal here 1, 2, since I'm using 1 here, huh? Times 1. So I have n plus 1 all square. Yeah, be careful when you write the n term. Okay. Now I will compare it with what? Now it's easy for me. Yeah, I'll compare it with the highest power in the numerator and denominator. You have what? My Bn conversion series. Let me say conversion series as we did before. Conversion series. What will be my Bn? N over n squared, which is 1 over n. This is diverge. Now do the limit. Limit an. My an is what? 2n plus 1 over n plus 1 square. And do the limit here. Limit an over bn as n goes to infinity. It will be what? Limit n goes to infinity to n plus 1 over n plus 1 square. Reciprocal of this, n over 1. So I have what? Same degree, 2 positive. So it means this series diverge by the limit conversion test. Okay. This one. What will be the n term? That will be the series. Be careful. N equal 1 to infinity. N equal, yeah, I'm starting with 2. So let me make it n equal 2. So I have 1 plus n ln n. Yeah, this is 2, 3, 4. So n ln 2 ln 3 ln 4. Okay, over. If my starting is 2, then this is, I have 9. It's not a square. This is what? 9, and this is 14, huh? I have 9, 14, 21. Yeah, I have 9 squared is 4 plus 5. I have 9, and when n equal 3, 9 squared is 9 plus 5. Good. And this is when n equal 4, that 9 squared, 16 plus 5, 21. So this is will be n squared plus 5. Good. I get an. Okay. Now I'll try to do, what will be the sequence which I will compare it with. Yeah. Let me try 1 over n, my comparison series. 1 over n. Let me see what will happen. I know this is diverge harmonic. So this is Bn, diverge harmonic series. Okay, that's diverge harmonic series. I'll do the limit. And this is An. An is 1 plus n ln n over n squared plus 5. Limit n goes to infinity of An over Bn. That will be limit n goes to infinity. 1 plus n ln n over n squared plus 5 times n over 1. Yeah, that will be limit n goes to infinity. 1 n plus n square ln n over n square plus 5. Let me divide everything by n square. So you have limit n goes to infinity. Yeah, that will be what? I have divided by n square 1 over n plus ln n over 1 plus 5 over n square. I divide everything by n square, numerator and denominator. Great. I get what? Now if we apply the limit, you have 0 plus infinity over 1 plus 0, which is infinity. What the limit comparison test said, that should be finite and positive. This is not finite. It's infinity. So I have this case. The limit of An over Bn is infinity. And also the series Bn diverge. So what I get, this is infinity. This is diverge. So this one will diverge. That implies the series 1 plus n ln n over n square plus 5 diverge. Yeah, so I use this case, number 3. So if I get 0 or infinity, there is a possibility I will get a conclusion. Yeah, if it is 0, I need the series in the denominator to converge. If it is infinity, I need the series in the denominator to diverge, so the other one diverge. And this is what happened in this case. Okay, 1 over root n ln n. How to do that? If you remember, when we have ln n, when we have ln n, where is it? We say ln n always less than or equal n to the power c, where c is any positive number for some k. Starting maybe not from 1, from a specific point. I don't care about that, because the series will do the same. So I have ln n for sure less than square root of n, which is n to the power half. Okay. So if you graph both, you will notice it. So that means 1 over ln n will be greater than 1 over square root of n. Now multiply by square root of n in the denominator, that will be 1 over n. That's it. This one, I know this series is diverge, harmonic series. And this one is bigger than, this is the smaller. And this is the bigger one. So the bigger one, it will do what? It will diverge. So through the comparison test. Yeah, now I have these exercises, quick exercises. We'll try to do them. and see what will happen. Okay. The first one, powers, huh? So I have my conversion series. Let me call it 1, 2, 3, 4, 5. In case 1, what will be my conversion series? I'll take Bn to be what? N over n cubed. 1 over n square. Do the limit as n goes to infinity. An over Bn. This is An, huh? This is my An. So that will be limit as n goes to infinity. N minus 2. Yeah. N minus 2 over n cubed minus n squared plus 3 times n squared over 2. Same degree, so that is 1 positive. So this series will converge. This series will converge by the limit conversion test with this one, which is we did. Second one, also it's easy. What will be conversion test? Conversion series. Pn will be what? I have n cubed in the numerator. In the denominator, I have n squared. N squared. I have n to the power 5. That will be also 1 over n squared. So it will be the limit as n goes to infinity, an over bn. That will be, yeah, why I need 2 here. That will be n squared, sorry, over 1. That will be 1, huh? Yeah. I don't know why I wrote T. 2, okay. So I have this will be limit n goes to infinity, 5n cubed minus 3n over n cubed, n squared, n minus 2, n squared plus 5 times n squared over 1. So the degree is 5 in the numerator, and the denominator is 5 also. And so the result is 5, which is positive. So both will, and this one is converging, huh? This one converge. P series, huh? This is the same, huh? So B series converge. P equal to. So this one is converged by the limit conversion test. Let me take the next one. N over n plus 1, 3. Summation n over 3n plus 1. Something like this. What is it? Yeah, to the power n. Where n equal 1 to infinity. Am I right? Yeah. I need to compare it now with another series. How to compare that? Okay. I know that 3n is less than 3n plus 1 because this is have plus 1. And so 1 over 3n plus 1 greater than 1 over 3n greater than 1 over 3n plus 1. Okay. N over 3n plus 1 to the power n. No, that will not work. Okay. Now we need to compare it with 1 over 3 to the power n. Yeah, I have n over 3n plus 1. This is less than 1 over 3. Is that correct? Yes, it's correct. Why? So let me do it now the other way. So I have 3n than 3n plus 1. Okay. Divide by n. N is positive, so I can divide by that. That will be 3 less than 3. Yeah. Let me get it the other way. I have n. I know I want this to be less than 1 over 3, which means 3n less than 3n plus 1. Do this with this. So how to get from this, how to get this one? Yeah, you divide by yeah, this one, do this times this, huh? So I have 3n less than 3n plus 1. So this give me this. So I have n over 3n plus 1 should be less than 1 over 3. So n over 3n plus 1 to the power n less than 1 over 3 to the power n. And this one I know is converge. This is geometric. Let me give it space because it's, yeah, I need this. I need to compare it with 1 over 3. Is this correct? Yes. Why? Since everything is positive, I have 3n less than 3n plus 1, which is always correct. So if I divide by 3n, now I start from this. Divide by 3n plus 1, I have 3n over 3n plus 1 will be less than 1. Now divide by 3, I have n over 3n plus 1 less than 1 over 3. And what I am doing. So I'm starting, forget about this. If I start from this one, then I divide by 3n plus 1, I get this. If I divide by 3, I get this. And this is what I'm looking for. And that means n over 3n plus 1 to the power n will be less than 1 over 3 to the power n. So, and this one, for sure, for specific n, huh? That for sure it's divergent. 1 over 3 to the power n series this converge, I mean, not diverge, converge, which is geometric with r equal 1 over 3, where absolute value of r is less than 1. If this is the bigger is converge, the smaller for sure will converge. So I have summation n equal 1 to infinity n over 3n plus 1 to the power n converge. Using what? Using the comparison test. Comparison test with this one. Okay. 4. Let me try to do 4. Squeeze it here because I need 4 and 5. Okay. 4. What I have ln n all square. I have ln n all square over n cubed. Over n cubed. So let me do comparison series 1 over n square, which is I know bn, huh? This is bn, the n term that you conversion. This is converge, huh? P series converge. This is the n term of it. So do the limit now. Limit n goes to infinity. An over bn. What is an? From the question, an is ln n square over n cubed. That gives me limit n goes to infinity. Ln n square over n cubed, reciprocal of this n square over 1. That will be limit n goes to infinity. Ln n square over n. To the limit, you have infinity of infinity. So I can do Lewitter's rule. So I have limit, make it x. Yeah, better to make it with x. Sorry. To do the limit. Yeah. I'm doing limit x goes to infinity. So I have what? Limit x goes to infinity. This is x. I have limit 2 ln x times 1 over x over 1. And that will be limit x goes to infinity. Yeah, x goes to infinity. 2 ln x over x. It's still infinity over infinity. I'll do L'Hopital's rule again. So limit x goes to infinity. 2 over x over 1, which is 0. And I know now I can use this. Now the limit is 0. They know this one converge, so for sure the numerator will converge. Limit is 0, and summation of Bn converge. That means the summation of An will converge. Now we'll do the fifth one. The fifth one, the trick is here. What is 1 plus 2 plus 3 plus n? Yeah, we know this. So my series is 1 over 1 plus 2 plus 3. That will be n plus 1 over 2. Oops. So this summation 2 over n plus 1. Okay. And this one, if you compare it with 1 over n squared, by the way, this is telescopic. You can't do it in telescopic, so it will converge as a telescopic series. Or you can do it with the comparison series with Bn equal 1 over n squared. Do the limit 2 over n plus 1 times n squared over 1, which is 2 positive. So this series will converge by comparison with this one, by limit comparison test with this one. So I did all of these 5 problems. Yeah, now we have some old exams questions. As I said in the previous video, or when I did 9.3, I will do some of these old exams questions, but later I'll combine all these exams questions which related to the convergence, to the test for convergence. So we have all of these tests, so that will give me more or broader view how to deal with these tests, which test to choose, which choose to start with, something like this. That will be done later. Okay. What we have here? He said, which one of the following statement is false? If n positive and the series converge. Series converge means the limit right away, the limit of an is equal to 0. So this is correct. I'm looking for the wrong one. So I'll prove everything is correct except one. 1 over an is convergent, divergent. Why? Because if the limit of an goes to 0, what will be the limit of 1 over an? That will go to infinity. So this one, correct. Since this one, the n term of this one goes to infinity, so it will not go to 0. So it will be diverged by n term test for divergence. Okay. What about this one? This one, I can do it this way. I know minus 1 to the power n, an, will be less than or equal an. If it is even, then it's the same. If it is odd, then it will be less, since an is positive. So, and this one converge. So the bigger one converge. So for sure, this smaller one is converging. This is correct also. Now we have this one. I will compare it with 1 over e to the power n, which is converge. Do the limit test, the limit conversion test. I have an over e to the power n times en over 1. That will be limit of an as n goes to infinity, and that is 0. And this one, I know it's a converge series. So for sure, I mean this one is a converge. And I'm dividing by, now look, I have, this is my an, call it cn, or call it what you call it, cn. Yeah, let me do it in writing it, because writing it to make it very clear. I'm using the limit comparison test. So I can say Cn, call it Cn, An over An, and I will use Dn. Who cares? Dn make it 1 over e to the n. This is, yeah. Now if this one converge, I know this one converge as a series. I mean, this is with the n term, since it's geometric. Then, yeah, geometric. Okay. And the limit comparison, with Cn over Dn, that will be limit An over An times An over 1, and that limit is 0. And this one converge, so for sure this one converge. So this is correct. This one is wrong. Why? Because what will be the, I know that sine n, An, will be less than or equal 1 times An. And this one converge as a series. And this is, so for sure this one will converge. So this is wrong. That will be the false statement. I wish it's clear. When I say converge, I don't mean the interim. I take the series, huh? The series converge, huh? Yeah, this one now. How to do this one? Yeah. If you notice, this is cosine pi over n squared plus 1. This is less than or equal 1 over n squared plus 1. And that will be less than or equal 1 over n squared. Since the denominator will be bigger, so the number will be smaller. So I converge, and this one is a converge series. This is a P series. Converge. So if the bigger one converge, for sure this one will converge. This is convergent by the comparison series. I mean the series converge. Huh? I'm talking about the series here. Huh? So the series of this converge by the comparison test. And this is my answer. 1 over 3 to the power n minus n. If we do the limit comparison test, I think it will do it with 1 over 3. So my comparison series, the n term, I mean, of this comparison series, Bn will be 1 over 3 to the power n. Do the limit, n goes to infinity, of 1 over 3 to the power n minus n times the reciprocal of this. Yeah. I divide by 3 to the power n, numerator and denominator. So I have 3 to the power n, let me do it in details, over 3 to the power n over 3 to the power n minus n over 3 to the power n. Oh, I need to do this limit, which is using L'Hopital's rule. Limit n goes to infinity of n over 3 to the power n. That will be infinity over infinity. So I need L'Hopital's rule. I have 1 over 3 to the power n ln 3. Now it's 1 over infinity, which is 0. So this will be 0. So this limit will be what? 1 over 1 minus 0, which is 1 positive. And this series, this one converge as geometric with R equal 1/3. So this series will converge by the limit conversion test with this one. Yeah. Oh, I have 3 series. I need to check. Let me do it quickly. I know that sine square n over n square. This will be less than 1 over n square. Very clear. So it's comparison test with this one, then this one converge. I don't think I need the details. For this one, I compare it with what? Comparison series will be Bn, the inter of that, n to the power half over n square, which is 1 over n to the power 3 over 2. Do the limit. That give me what? Square root of n over 2n square minus n times n to the power 3 over 2 over 1. That will be limit n goes to infinity n square over 2n square minus n, which is half positive. So this one also converge. Since this one P series converge. What about this one? Yeah, I noticed tan inverse. Yeah, tan inverse n over n. Yeah, I know tan inverse. Let me do this. So I have this is convergent, this is convergent. Very clear. I know that tan inverse of n is between minus pi over 2 and pi over 2, actually without equality. It cannot be equal. And pi over 2. Okay. So if we try, I divide by n, this one would not help because this one diverge, I mean. It's bigger, so that will not help me. That will do nothing with me. But the other way, when I say tan inverse n over n greater than minus pi over 2 over n, I'm dividing by n, which is positive. And this one will be diverge. The smaller series diverge, that means the bigger series will diverge. So the only convergent series are 1 and 3. 1 and 3. The others are diverging. This one, he see this series when it will converge. So I will compare it with what? I will compare it with 1 over n to the power p into the power q. This is Bn, which is 1 over n p plus q. Then I will do the limit test. I know this one will converge if p plus q greater than 1. So if you want this to converge times n to the power p plus q, so for sure this will give me what? Will give me 3 positive. Check the limit later. Divide, do something. This is n to the power p plus q. N to the power p plus q. Positive, so that means this series will converge of what? If this series converge, and this series will converge if p plus q greater than 1. That will be my answer. The sum of 2 series. We know that if one is divergent and the other convergent, for sure the sum will be diverge. Okay. So if you look at this one, sine over 1 sine 1 over n to the power 4. I want to check this series. I compare it with what? Compare it with 1 over n to the power 4. That will be my Bn. Do the limit comparison. limit n goes to infinity, sine 1 over n to the power 4 over 1 over n to the power 4. Let t equal 1 over n to the power 4. What you will have, limit t goes to 0. As n goes to infinity, that will 1 over infinity, which is 0. Sine t over t, which I know it's 1, positive. So this limit positive, and this one converge. So that means this series will converge. Now come to the next one. This series, 1 over ln n to the power 4. No worries. This is what? 1 over 4 ln n, which is 1 over 4, 1 over ln n. And I think we did that before. This is diverge. 1 over ln n, I think we did it somewhere. Yeah. You can compare it with 1 over n. I'm not sure. Yeah, we did it before. You can check it later. 1 over ln n. Let me see it quickly. Yeah, we did it here. You compare it with 1 over n. So it's divergent. So convergent plus divergent, for sure it gives me divergent. So this is my answer. Divergent because this series diverge and this series converge. N over n squared by 2. Yeah, very clear. This one, my Bn will be n over n squared, which is 1 over n. Okay, so I have the limit comparison test, n over n squared plus 1 reciprocal of this. That gives me 1 positive. So it diverge by the limit comparison test. This one, k sine square. Okay, yeah, if you look at this, that will be k sine square k over 1 plus k cubed. This will be less than k over 1 plus k cubed, since sine cannot exceed 1. And this one will be less than k over k cubed, since this is the denominator is more. And this is what? 1 over k square. So I have this is less than this, and I know this one converge P series. Huh? So that implies this series will converge. So this is my answer. Converge it by using the comparison test with this one. You know, this one he said it converge. So I will do the comparison with what? With 1 over n to the power 2p with this series. This is my Bn. So I do the limit test, and this one, when it will converge, this one converge if 2p greater than 1, which means p greater than half. So let me do the limit comparison test to be sure. So I have 1 over n squared plus n to the power p times reciprocal of this, which I can make it this way, make it inside. So I have, this is n squared over n squared plus n to the power p. Take the limit inside, that will be 1 positive. So this series will converge if this series converge, and that will means if b greater than half. But that will be my answer. Okay. This series 1 over n, 1 plus 100 over n. Yeah. I will make it with 1 over n. Compare it with this. What will be the limit as n goes to infinity of 1 over n, 1 plus 100 over n, times n to the power 1, when n over 1. That will be what? Limit as n goes to infinity of what? That will be n to the power 1 minus 100 over n. That give me limit n goes to infinity of what? N to the power minus 100 over n. Okay. And that is what? Limit n goes to infinity 1 over n to the power 100 over n. Okay. How we can find this limit? N to the power 100 over n. Okay. Yeah. Well, let me try to do this limit, which is the same. This limit is what? Is infinity to the power 0. Is it correct? I took this as a power with a minus sign. Yeah. So undetermined. So I need to do this limit. Limit as it goes to infinity, x to the power minus 100 over x. So I take ln of both sides. That give me what? That give me minus 100 over x in x. Okay. So I have what? Limit as x goes to infinity of ln y will be limit x goes to infinity of this minus 100 ln x over x. That is infinity over infinity. So do the limit, do the derivative. That will be minus 100 over x over 1. That give me 0. That's the limit of ln y. So what's the limit of this? Will be e to the power 0, which is 1, positive. I know this diverge. So by the limit comparison test, this series will diverge too. Yeah. Since the limit, when the comparison test, the limit comparison test, I'm getting this where I did, and it's going to 1. And when I take the limit, it goes to 0. So e to the power 0, that will be 1. So according to the limit comparison test, both should have the same thing. And I know this one diverged, so this one will be diverged by the limit comparison test. Yeah, tan inverse n over n cubed. Yeah, very easy. Yeah, this one will be less than pi over 2 over n cubed. So compare this with this series, and I know this is P series, converge, and this is the bigger, so for sure this series will converge by the comparison test with pi over 2 n cubed. This one, what will happen? Yeah. I know I have cosine to the power 4 n square plus 1 over n plus 1 all to the power 3 over 2. I don't care. This is will be less than or equal 1 over n plus 1 to the power 3 over 2. And this for sure will be less than 1 over n to the power 3 over 2. Why is that? Since I know that n plus 1 greater than n, so 1 over n plus 1 will be less than 1 over n. So for sure 1 over n plus 1 to the power 3 over 2 less than 1 over n to the power 3 over 2, which is this one. And this is P series converge, since P equals 3/2 as a series, I mean. So for sure, comparison test give me this series will converge. I mean, here's the series, huh? The series convergent. Yeah, the series is convergent. There is no meaning of the interim, but usually we would do it this way. This is the last one, I think, yeah. This is the last one. So let me do it quickly. Yeah, I compare it with what? 1 over square root of n times square root of n, 1 over n. Do the limit comparison test. I have 1 over square root of n plus 1 times n over 1. Do the limit. I have, this is 1. So for sure, this is 1 greater than 0. So since this series diverge, then this series will diverge too. By, but you can do it by limit comparison test also. Yeah, I did the limit comparison test actually. Limit comparison test. Yeah, I think we did good numbers also from all the exams. But as I said later, I will do exams from. Yeah, I will do all the exams where I have all the 4 sections. So that will give me better clue how to choose which method to choose to deal with these problems. Yeah, I will stop the recording. I think now we're done with this section 9.4. So I'll do later, inshallah, 9.5. Thank you. Oh, the recording.